Welcome, brothers. I am so glad you're joining me for this explainer today. We're going to focus on one of the absolute most critical maintenance procedures in our ultra-pure water facilities, and that's executing a flawless clean-in-place, or CIP procedure for our reverse osmosis membranes. Look, I've spent years operating these exact systems on the floor, and I can tell you from firsthand experience that getting this right is literally the difference between a smooth-running plant and a catastrophic contamination event. So take a breath, settle in, and let's walk through the exact standards we need to protect our equipment and really maximize its lifespan. Our agenda for today is straightforward. We'll cover 4 clear areas. 1. The ROCIP system. 2. Triggers and common mistakes. 3. The 10-step CIP procedure. And finally, 4. Safety warnings and takeaways.
All right, Section 1, the ROCIP system. Let's lay out the hardware and the foundation. So let's think about the anatomy of a standard CIP skid. What are we actually working with here? Well, it's a closed-loop system built around a 316L stainless steel tank, which is usually insulated, of course. We've got a dedicated circulation pump, a heater to dial in our temperature, and 5 to 10 micron cartridge filters on the return line. But the absolute priority here, brothers, the thing you can't compromise on is isolation. Before a single drop of chemical even thinks about flowing, we must completely isolate that RO train from the rest of the UPW plant using strict lockout/tagout procedures. We're creating a closed loop to keep those chemicals safely contained.
Okay, let's talk chemistry for a second. For the thin film composite, or TFC membranes we have very specific tools for very specific jobs. We use a low pH citric acid to break down inorganic scale, and a high pH sodium hydroxide solution to really attack organic fouling and biofilm. Now, if the biofouling is severe, we might bring in peracetic acid or sodium bisulfite. But hear me on this, and this is absolutely crucial. We exclusively mix these chemicals with RO permeate or DI water. Never, under any circumstances, use raw or chlorinated water. Doing that will just instantly, permanently destroy the polyamide layer of the membrane.
Moving right along to Section 2, triggers and common mistakes. How do we know when it's time to act, and what shouldn't we do?
Greater than 10 to 15%. Guys, this number is your absolute trigger. When you see your normalized permeate flow drop by more than 10 to 15%, or your differential pressure, your delta P, increase beyond this threshold, it is time to initiate a CIP, no questions asked. An increase in normalized salt passage is another really clear warning sign. If you ignore these signs, the fouling or scaling is just going to compound, and you honestly risk losing the membrane entirely.
Now, let's look at what goes wrong, because these common failures are exactly what we have to prevent on the floor. I've seen operators skip the pre-flush phase just to save a little time. But when you do that, the high TDS concentrate left in the vessel violently precipitates the second it meets the cleaning chemicals. It's a mess. I've seen people ignore the CIP cartridge filters, which means they're basically pumping dirty abrasive fluid right back into those delicate membranes. And I've actually seen engineers directly mix acid and alkali in the same tank, creating a super dangerous neutralization reaction. Not to mention, failing to wear full PPE, like face shields and chemical gloves when handling these concentrated chemicals, that's just an absolute failure of safety.
So what does correct execution look like? The correct sequence is almost always alkali first to remove the organic fouling, followed by acid to dissolve the mineral scale. If you reverse this, if you use acid on biofouling first, you are literally just baking the organics right into the membrane. And please, notice the temperature limit. For TFC membranes, exceeding 45 degrees Celsius guarantees permanent, irreversible damage. If you let that heater run unchecked, well, you're going to be buying a whole new rack of membranes. All right, on to Section 3, the 10-step CIP procedure. Let's walk through the actual execution, step by step. We actually start before we even touch a single valve. Step 0 is assessing the data, identifying the foulant, and checking your safety data sheets. Step 1 is isolating the RO train. You execute strict lockout/tagout on the feed pump and valves, completely cutting it off from the downstream plant. Step 2 is super important, the low-pressure flush. Using permeate or DI water, we gently flush the vessels at under 30 psi. We keep doing this until the drain water conductivity drops, which proves we've pushed out all those loose salts. Only then in Step 3 do we actually mix our CIP solution, carefully bringing the temperature to that sweet spot of 30 to 35 degrees Celsius. Moving to Step 4, this is the mechanical connection. We hook up our CIP supply hose to the RO feed header and our return hose from the concentrate header back to the tank. Step 5 is the main event, circulate and soak. We start the CIP pump nice and slow, circulating those warm chemicals for 15 to 30 minutes. Then we turn off the pump and just let it soak for 15 to 60 minutes. You have got to monitor the pH and temperature closely during this phase. If the pH drifts significantly, it usually means the chemical is exhausted and you might need to adjust it. Finally, step 6, we safely and completely drain the spent, dirty solution out of the tank to the wastewater system.
We're in the home stretch, but this final phase requires absolute patience. Step 7 is the final DI water rinse. We circulate fresh water until the return line conductivity perfectly matches our clean feed water and the pH normalizes to between 5 and 7. You might need to repeat this 2 or 3 times. Do not rush it. Step 8 is our final visual check for foam or color in the drain, removing the temporary hoses, lifting the loadout, and initiating a very slow, low-pressure restart of the RO feed pump to avoid mechanical shock. And step 9, that's your responsibility to the next shift. Log the new baseline performance data and complete a solid handover. Finally, Section 4, Safety Warnings and Takeaways. These are the rules that are written in stone. Brothers, listen to me. These safety rules are non-negotiable. Before you ever loosen a temporary CIP hose connection, you must physically confirm zero pressure on the gauge. Taking a chemical spray to the face is 100% preventable. Also, when hooking up, use only clean, chemically compatible hoses. Never use those standard black rubber hoses. They will leach contaminants directly into our UPW system. Make sure your area is fully ventilated when mixing these solutions, and honestly, perhaps most importantly, never ever run the main high-pressure RO pump during a CIP operation. We solely use the low-pressure CIP circulation pump. I really want this golden rule of the CIP process to just sink in. Low pressure flush, chemical cleaning, thorough rinse, return to service. It is an unbreakable sequence. Think about it. If you shortcut the flush, you cause precipitation. If you shortcut the rinse, you are sending chemicals straight down the line into the clean room. We also have to be realistic about what this procedure can actually achieve. CIP is an amazing maintenance tool, but it's not a miracle cure. It cures fouling. It does not cure mechanical damage, like telescoping or a torn polyamide layer. So if you run a CIP and the normalized flow doesn't recover, and you run a second cycle and it still hasn't recovered, well, the element is compromised. At that point, you just have to pull it and replace it to protect the fab's production schedule. So this all brings me to a final question for you to really think about. When was the last time you personally checked your plant's normalized flow data before initiating a CIP? Are you just reacting to alarms, or are you proactively trending your delta P and normalized flow? I challenge you to log into your SCADA system today, pull up those trend charts, and know exactly where your membranes stand. Thank you so much for your focus today, brothers. Stay safe out there on the floor.